Engineer Balan Sundara garu to the webinar. Welcome, sir.
Morning.
I welcome today's speaker, Mr. Shubham Baranwal and team of Nebras Technologies Private Limited to this webinar. Welcome, sir.
Thank you, sir.
Now I request Chairman of this center, Engineer Balan Sundara garu, to say a few words about today's webinar.
To all. As part of our regular program, this webinar, monthly webinar, is conducted today on the subject drone survey and its importance in civil engineering. We are highly thankful for the Shubham Baranwal and team for immediately accepting our request and for this presentation. What is a drone survey? What is drone? A drone is an aircraft without any human pilot or crew or passengers on board. The use of drone or unmanned aerial vehicle, that is UAV, to capture aerial data with downward facing sensors such as RGB or multispectral cameras and radar payloads. Drones are used for surveying, are equipped with onboard cameras that take photos of the ground from different points in the air. Images are tagged with geo coordinates that are captured by a GNSS sensor on the drone, indicating exactly where that image is located in space. The major applications are 2D mapping, 3D models, volumetric survey, radar map, visual surveys, thermal surveys, agricultural surveys, etc. The detailed information and the procedure will be explained by Shubham Baranwal and team. Thank you very much. I expect all will.
Thank you, sir. Recently, in this month, ACCI inaugurated its two centers, Trichy and Puttur, on 11th and 17th. Congratulations from Kakinada Center to the new team of new centers of ACCI. As all you aware, Kakinada Center is one of the most active centers of ACCI, continuous knowledge sharing activity and trying its best to bring updated technologies to the members. In this month, we came to share with you the trending and advanced technology, drone surveying technology. Drone surveying is an aerial survey conducted by using drones, special cameras with downward facing sensors which capture the aerial data. It has the advantages of timely, accurate, and safe method. Traditional surveys will take days. With drones, we can complete in hours and data can be processed on the same day. It's a cost-effective, much lower cost than traditional survey, which reduces the cost of data acquisition. We can easily access those areas of difficult where traditional surveys are challenging and time-consuming. It will helpful in exploring unsafe places. With the drone surveying, we can 90% faster than manual surveying methods. It helps in creating highly accurate maps and survey points. Hope this webinar will help you a lot sharing the knowledge of drones in surveying. Without late, I am inviting today's speaker, Mr. Shubham Baranwal, co-founder and director of Nebras Technologies Private Limited, popularly known as Surveyan. He is an electrical and electronics engineering graduate from NIT Meghalaya. He founded Surveyan along with two other co-founders, Abhishek Acharya and Amit, in the year 2019. And since then, Surveyan is served more consumers in India. I welcome Shubham Baranwal to start the lecture.
Thank you, Durga sir. So, first of all, I would, on behalf of Nibras Technologies Private Limited, we would like to thank ACE Kakinada chapter to invite us to impart the knowledge about drone surveying and its output. So, so today's webinar is based on drone surveying. Before moving myself founded this company. Hello.
Yes, sir.
Okay, fine. So Abhishek, Amit, and myself founded this company. We were very enthusiastic about robotics, and when we started, we thought of doing something with a very more advanced technology, which was a drone technology. And then when we started working on it, we found it very complex. But one thing we made sure, like when we present it out in the market, it should be very affordable and very easy to use. And this is how Surveyan was born. So we operate under the brand name of Surveyan, and we have two products in the market. One is the drone itself, and another is the drone data processing software, which processes the drone data. So this is about who we are. Right now, we have more than 150 plus clients all over India who are using drone and our software. And let me tell you this, that we have customers only in MSMEs only. Now, coming to this presentation, so I would be talking about what drones are, how they are helpful over your traditional methods, what are the types of drone you need to choose when you are doing a land survey, and what are the outputs and how we can use it in our day-to-day work, mostly in AutoCAD. Fine. So, as Durga sir already told about the traditional methods, like there are several advantages of drones over total stations DGPS. So this is a chart which we have prepared, and this shows that the drone works 10x faster than your traditional methods. So the first thing is like about the data collection. It is where the difference comes in. For let's say for 100 hectares, you may need to work for 1 to 2 weeks of a time to collect the data point by point, using total station or DGPS. Whereas this data through drone can be collected within hours only. Then to post process this data, you take another 1 or 2 days. Whereas this 100 hectares of data can be processed in maybe 1 hour or 2 hours. And then the most important thing is the delivery of results. So to prepare the results, you need to plot everything in AutoCAD, and then you need to deliver it to clients. In drone survey, we get the outputs automatically with a very few clicks of a button.
Sir, some of the participants requesting for loud voice, sir, a little loud voice.
Okay. Is it fine now?
Right, sir, carry on.
Okay. So I'll just repeat. So I has already told about what are the advantages of drone. Now I would just tell you where the difference lies between the drone survey and the traditional ground survey. The first thing, the main difference lies between the data collection part. So when you go for a traditional method, you need to let's say for a DGPS, you need to set a base, then you need to, it takes many hours, and then you need to take points manually using rover. Same is the case for the total station. But whereas in drone survey, you set up the drone in less than 5 minutes and you plan the survey and you fly the drone. It would fly and it would capture data within few hours only. Then the delivery of result is where the main time takes place. So a person needs to do manually post processing, and he has to deliver the results, he has to plot everything on AutoCAD. Whereas in drone survey, all the things come automatically, the outputs and all the contours come automatically. So this is where the difference lies. Definitely what sir has told is like data can be collected very fast. One important thing is like the surveyors don't need to climb hazardous place, or like they don't need to climb difficult terrains. They can fly drones safely, and then the quality of results, the resolutions produced by drone survey is 100x more than what we get from the traditional survey. And with all these advantages, we get the one thing is like we save our time, and ultimately this is cost effective. Now coming to like how this whole system works. So it may, you may find it like the drone survey is very advanced technology, but we have made it such simplistic thing, like you can set up the drone in less than 5 minutes. Then you generally have a ground control station software through which you plan the drone, you upload your KMLs, and you plan the drone, and you control the drone, and you ask the drone to fly. Then the drone automatically flies to the planned mission. It collects the data automatically. The data means here is the drone collects the photo. Here drone acts only as a data collection medium, and the rest of the thing is done by the photogrammetry software. So the drone flies to its designated path and collects the photo. Once the drone completes its mission, it would land back to its takeoff location. Now the surveyor has to come to the office, he has to transfer the data, and then he has to upload it to a photogrammetry software, which I would explain it later. And then he would start processing the result and he would get the result. This is very much simple. So now I'll come to the type of drone which you need to choose while you are doing land survey. First of all, you should make sure like the drone is lightweight and it is capable of capturing more area in less time. So like our survey drone has a capacity of like flying 25 to 30 minutes, and it can capture up to 60 hectares in one flight. So you can imagine like in 30 minutes you are able to capture 60 hectares, which is impossible with the traditional methods. It should have a high resolution camera. Generally in government side, you would be asked to have a 20 megapixel camera. We have 23 megapixel camera, and the drone should be able to operate at high altitude also, so that it can capture more photos. Now coming to one thing, you should also make sure like the drone should have important fail-safe features so that there is less chance of avoiding crashes. So in our drone we have 4 to 5 fail-safe features, like the drone would automatically return to its takeoff location if there is a low battery, if there is a high magnetic or power interference. Now here the drone is acting as a data collection tool. So the important thing here is camera. So in case the camera is switched off or the connection gets lost because of uncertain reasons, so the drone would return to its home location, because if the camera is off, means there is no point of flying the drone. Also, like we have a failsafe feature, like when there is a gust or when there is a very high wind blowing. So the drone would automatically come to its uh, home position. Apart from this, sometimes we have given a manual control also, so that if a person flies a drone and if he finds like the drone is behaving unusually, so he can pause the drone using the hover button, or if he finds like the drone is behaving very aggressively, he can press the land button immediately and drone would land there only. Or if he finds like, okay, drone is something behaving unusual, he has a return to home button where he would press the return to home button and it would come back to its home location. So these are some of the fail-safe features you should consider while choosing your land surveying drone. Now comes the control application. So we in drone survey, we something is called ground control station. So it can have a hardware and also it can have a software. Our drone is completely autonomous and it is controlled by a GCS software which is available on the Android phone. So you need to log into the Android phone and you need to connect it to the drone. Now, in this GCS software, you would see like there are few parameters of the drone, like the battery, the number of satellites it is catching, at what height it is, at what speed it would be flying. Then we have like the camera battery also, and then we have a few more features like you can calibrate the sensors of the drone if if it is required. Then you can test the motors, you can test the camera also. Now comes the main part, which is the mission types which you need to be considered. So in our application, we have three types of surveys. One is land survey, another is corridor mapping, and the third one is the rooftop survey. First, I will tell you about the land survey. Land survey can be done for, let's say, mining, irrigation, or any basic land survey you can do. In this, you would have a plus button here. You can see on the 15th number, there would be a plus button. You need to click on this and you would get three options to select the type of survey. So the land survey is basically a survey where terrain is given and you need to plan the mission. Here you can like upload the KML also. Three things you need to see here. One is the one you can see is the overlap, another is altitude and the angle. So the overlap means here like the how many lines drones needs to cover. So in general, we have a practice of giving 80% of overlap, but when it comes to like a dense forest or when it comes to building, you need to give high overlap. High overlap means more photos would be taken, so the quality of the result would be better. But more lines means that drone will take more time. So it is a trade-off between like how your client wants your result. If he is asking for a very high resolution result, then you go for a high overlap. If the in general, if the results are like you need a decent result, then 80% or even 75% works. Now comes the altitude part. So the drone can fly from 25 meters to 120 meters. Again, when you are flying at a low altitude, the number of lines would be more and the resolution would be very much better. But in general, like 70 to 80 or 100 meters, the means the altitude is fine. So in this case, this is also a trade-off, like what your client wants. If he wants a very high resolution, you can fly at a very low altitude. But in general, if a client wants a decent result, then 80 meter, 100 meter, or even 120 meter is acceptable. So this is how we need to plan carefully. Then the another type of mission comes is corridor mapping. This is related to your canal mapping or your road surveys or your railway surveys. So you would see in general land survey there was a polygon. Now in this corridor mapping, you would see there is only a polyline. So you need to uh, draw the polyline, or you can upload a KML, and in this way the drone would fly to its designated area. Okay. Now comes the rooftop mission. So this type of mission is a special type of mission where if you want to do a monument survey, or if you want to like do a survey for building, then this type of survey is considered. In this survey, when you consider, let's say for a monument survey, a very high 3D model is required. So in this survey, we have a combination of two surveys in this type of mission. One is like you need to fly like a general land survey so that it can take a photos from the top, and then also since the land surveys take photos only from the top, and in rooftop mission we need to means have a good 3D model also. So we take a circular motion around the building, or let's say monument, and then we fly the drone. So in this way there are three types of missions which needs to be considered. Okay, so this is all about the drone. One thing before moving forward, I would like to tell you, like at the end of this section, we have a quiz also, where like you would be given 10 to 12 questions, and each question would be carrying marks. And at the end of this, after QA, we would be announcing the results, and the winners would be getting exciting goodies also. Okay. Now let's move to the software part now. So the software part is, I'll tell you. So the software which processes this drone data is called as the photogrammetry software. So how this photogrammetry works is like we have a so the drone collects data, a very series of data. These data are geotagged photos. Now these photos are stitched together, like from the photos the features are extracted, and these photos are merged together, and then these photos are merged together, and then a stitched georeferenced map is generated, and uh, on top of it we would get a results like orthomosaic, DSM, DTM, and from there we could extract data which are AutoCAD compatible. So let me go through our software and tell you how this software actually works. So this is the Surveyan software. Here you need to like log in and you create a new project. You give a project name. You give a survey date. You give your phone number. Then you select the type of survey. So I already told about general land surveys, corridor mapping. So you need to select a general land survey, or maybe corridor mapping. Now there are two types of surveys which can be done. Either you can do it without GCP, and if like the client requires more accuracy, more precision, then you should select GCP. GCP has a little more workflow. I'll go with the without GCP part for the time constraint. Then you need to upload the photos. So I'll just, you can select your boundary also. So once the photos are uploaded, what you need to do is just your work gets over. You just need to click on start processing and the result would come out. This is very much simple. So you just have flown the drone, you uploaded the KML, you just collected the data, and then you have just uploaded the data and you have just given a single button click start processing and it would automatically process and the results would come out within an hour. This is how easy it is. I'll tell you what, meanwhile, while it processes, I'll tell you a project which we have already done. So this was a GCP based project. You can see like there were few GCPs placed around, and I'll just pop into the output section. So the first thing which you would see is like this is a georeference 2D image. So there were, you can see like there were multiple photos clicked on the side, and these photos are stitched together and a single map is generated, which you can see. This is called an ortho mosaic. Okay, so this is also a georeferenced image, and the means it has a latitude, longitude, or XYZ, XY, and then you can see the textures over it. So when you see like there are trees, there are like roads going on. So, and the best thing is it can be imported on the AutoCAD, which I would show you how you can do it. So if it is imported on the AutoCAD, you can easily like digitize it. You can like easily see like where trees are there, where trees are not there, where road is going. So it is easy to plan out everything. So this is one of the output. Another output is your elevation model. Now this elevation model means this is also a 2D georeferenced image only. The difference between orthomosaic and DSM is like DSM contains the elevations of each and every part. So you would see like it is ranging from 156 to 205 meter. So 156 is around here where you can see there is a low height, and 205 you can see the height difference is more. So DSM and one more elevation model is there, DTL. So in these two you get a elevation. Now the difference between this is I am showing DSM. We have one more DTM also. So let me go one by one through some of the measurement tools, like what it is. So one thing is like you can have a location. The location can be of anywhere. You can see northing, easting, the zone, and the altitude, which is calculated from the backend. So the altitude is calculated from the backend. It loads the DSM in the background and then it gives. So you can see altitude is 195 meters. So you can hover anywhere and you can see the altitude would change accordingly. So whereas if you would be using DGPS or total station, it would be very difficult to get points at each and every point. But here you can see like you hover anywhere, you get northing, easting, and the altitude. The next thing is like since you would be able to see the textures on the map, you can easily figure out, like you can easily mark where to where get the distance. So this This way you can get the distance of any point or like from any one point to another point. Then comes the main part, which is the profiling, which many of us generally go. So you would see like this way you would get a profile of any terrain. If you want to change, you can get the profile of any terrain. If you would just click how the land is going, you would see it. Now here I would tell you the difference between the DSM and DTM. So already I told you about DSM, where like you would get DSM and DTM are the elevation models. So you get a elevation with respect to northing and easting or with your coordinates. So in DSM you would get your surface objects like trees, buildings, or any objects present on the ground. Whereas when it comes to DTM tries to smooth out or filter out the objects present on the surface, like the trees, buildings, cars, for that matter. So right now you are seeing an output using DSM. I'll just click and use DTM, and let's see like whether the trees gets filtered out or not. So you would see like the trees have been chopped off. You can see the elevation difference is close to 199 only. Whereas if you just use the DTM, you would see like the trees are going around 200 meters, something like it. You can see it more clearly in QGIS. QGIS is an open source software where you can import these DSM, DTM, and Ortho Mosaic. I have already downloaded it. I will just show you for the. I hope my screen is visible to everyone, right?
Yes, sir. Visible, sir.
Yes, it is visible.
Okay. So this is QGIS. Now you can see like I have imported this Ortho Mosaic here, and you can see that trees and all the textures of the Ortho Mosaic. Now this is DSM. This is a non-textured uh, data, and here you would have a elevation only. This is DTM. So now when I unclick this DSM part, you would see there is some filtering going on. So this is what DTM is. In DSM, you would see trees and other objects present on the surface, whereas in DTM, you would see that things have been filtered out or tried to smoothen out. So this is the main difference between DSM and DTM. And then this is Ortho Mosaic. One thing I would like to tell you, like I told you while flying, you should consider the overlap and the altitude. So how it affects the ortho photo. So you can see like the resolution of this photo can be determined you by going to the properties, and you can see like you would see like the pixel size. This pixel size means like how much pixels it is in meters. So 0.022834. This means like every pixel you are moving 2 centimeters. Let me show you this thing. So when this is actually an image, so you would see these are made up of pixels. So when we say like 0.02 centimeter per 0.02 meter per pixel, so you would see like when you are moving from one pixel to another pixel, you are moving means 2 centimeters. So this is what a GSD means, ground sample resolution. For Ortho Photo, it would be high resolution. For DSM DTM, it would be low resolution. Now, so I hope you are clear with this DSM and DTM, which are one of the most important outputs of the drone survey. Now, after that, you can measure the.
Can I ask a question, please?
Yeah, sure.
This is Rajkumar. This what we do KML and KMZ is a DSM and DTM.
No, sir. KML and KMZ are different formats altogether. They are the formats from Google Earth, and these are actually vector data. Okay, so
Okay.
these contains points, lines, whereas DSM, DTM, and orthomosaic, you would see these are continuous data, right? So you would see like these are continuous data, whereas KML or KMZ, you would have points, area, polygon in KMZ or KML. So altogether, those two are different things.
So this is basing on that is in a Google platform. This is another platform. So you are calling it the DSM DTM, right?
No, sir. DSM, DTMs are the output only. So you have seen Google Earth, right? Google Earth, if you go in Google Earth, you would see a satellite image, right? So that is a very means low resolution image. When you compare it with drone survey, it is a very high resolution, and you get the same type of imagery only. So you get a like a Google Earth imagery only, and on top of it, you would get DSM and DTM, which are geo-referenced raster data or 2D data, where you would get elevations at each and every point.
So this drone, you have any specific configurations of the drone or any auto picking up the control points and doing things any drone can do, or any specific resolution drone is required?
So, sir, basically you need a survey grade drone to perform these types of survey. And we recommend like the drones which have a high resolution should perform better. And the points which I told you, like you should consider fail-safe features as well, and then the time taken. These all things you should consider while choosing the drone. So means any drone can perform, but then it comes to the quality of the photos it is taking, and then how it is getting processed. So these are the things which needs to be taken care of.
Okay, thank you. I'll discuss with you in person.
Yeah, sure, sir. Okay. Now we can measure the area also, like of any. So you get a area, and similarly we can measure the volume as well. So let's suppose you want to measure the volume. So you can measure the volume also. So you get a cut volume and a fill volume. Here we have different types of methods, like you need to choose a base elevation. So on top of it you would have a cut volume, and on below it you would have a fill volume. So there are few methods through which you can use cut and fill volume. You can get the cut and fill volume. Now comes the interesting part, I think, which most of you are mostly interested in, and is like how to generate contour from this, or how to generate grid points, or in fact for road surveyors, you would be very much familiar with the LC section. So how to have a LC section. So I'll start with this contour part, like how you can generate contour part. So in contour, you can have like you can decide the contour interval, like at how many contour intervals you need to get the interval. Then this area of filter, since this is all computerized, you get the, and the DSM and DTM are of at a very high resolution. So you sometimes you get a very misleading contours like very small pebbles or something. So this can be filtered out using this parameter. Generally, 50 to 100 parameter is fine. Then if you want to like have major contour intervals, so you can like at what interval you want to have a major contour. So you can give this option also. And how many means how labeling should be done per contour. So I'll just give. Now what you need to do is just click on this generate button. So it would automatically process and it would give the results in few seconds. So you would see that it has been automatically generated. Let me just download the results.
What is this software?
Sir, this software name is Survey and Geo Workspace. It is a completely cloud-based photogrammetry software. So now I'll just move on with the contour part. So you would get three types of outputs. One is DXF, which is AutoCAD compatible. Then you get a PDF, and then you get a shapefile, which is GIS software compatible. So I'll just open contour in AutoCAD.
ఏమైంది రింకు?
So you would see contours being generated, and these are geo-referenced contours, and mostly these are 3D contours. So if you can see, these are 3D contours. And then we had the option of major contours. So at every 5 meters, the major contours are also generated. These are labeled also. One thing I would like to explain is like how we can import AutoCAD, import OrthoMosaic into AutoCAD. So this is a OrthoMosaic file which we can download through the software.
Mosaic and AutoCAD, the boundaries are mismatching.
Let me show you, sir. Like it is not mismatching. I'll just tell you. So this is when in AutoCAD, when you import OrthoMosaic, it is imported as a normal image only. Now we need to geo-reference it. So we get a world file with it, and you get so the world file is like it would give you the coordinates, it would give you the resolution, and it would give you the coordinates like from where to where the map has to be aligned. So in this we have a tool called GeoRef IMG through which it can be aligned. So you would see like now you would see like the contours have been aligned with this OrthoMosaic. So this is how you can import OrthoMosaic, and you can like generate contours also. The good thing about here is like when you import OrthoMosaic, you can see like trees, you can see the roads and all going on. So when it comes to digitization, you can easily like use your AutoCAD tools and mark the ortho mosaic and plan very easily. So this is one of the part of contour. Now comes like if you want to generate a grid point. Let's suppose sometimes you want to use some other software also, and you just need to import grid points at every, let's say, 10 meters. So you can do that also. So this is also done automatically. You just need to select your parameters and you just need to click on this generate button. This is also done automatically. So in this you get a AutoCAD compatible format, a shape file, and we have a CSV file also. So let me open a CSV file first. So here you would get like your X, Y, and Z. So at every 10 meter you are getting an elevation. So this is X, Y, Z in CSV format. So you can see like almost 620 points have been generated. Now I'll open AutoCAD file. So you can see like all the grid points have been generated at every 10-meter interval, and this is also 3D points. So you can see like the points are in 3D space. So we have X, Y as well as the Z parameter. So it is labeled also, and in fact if you click on any point and see the property, you would see like the X, Y, and Z parameter. Now comes another interesting part, which is for mainly road surveyors or railway surveyors where corridor mapping is used. So we have a LC section, we can generate a LC section also. So let's suppose you want to generate LC section, and so you can like define how many L sections you required, what should be the gap between. So you can see like how many, in this way the profile would be given. So you can see like there are 3 L sections and there are multiple C sections. Then you click on this profile button and you would get the profiles of each and every section. So if you click here, you would get a profile like this. If you click on the L section, you would get a profile like this. And the good part is you can export it also.
So a lot of CS and LS problems are sorted.
I hope, sir. So all these things are like 24/7 available in this software. This is like your software only. Your team members can work, means multiple members can work on this at the same time. It can generate automatically. It's not like you need to ask us, means when it comes to cloud-based online software, you don't need to ask someone like, okay, give me this format, give me this format. Everything is available at the tip of the user only. So in this way, you would see like the LC export section is there. Means we have exported the LC section. Okay. So in this also we have three formats. One is the PDF format, where you would see LC section. The naming is there: L1, L2, main, C1, C2, C3, and the profiles are there. This is just the PDF part, where you would get all the profiles. Then we have a CSV format also, where you would get the section name at each distance, what is the elevation, what is the easting, northing value, latitude, longitude value. So let's say for C1, these many points were generated. So at each and every distance, like at 18, at 20 meter from the left and 20 meter from the right, the distances are given. In this way, C1, C2, C3, like that, L1 and L2, and the main thing is given. And another thing is like the AutoCAD compatible format. So you can see like these are the C1, C2, L1, L2, and we have the profiles being given. Like the C1 profile from each distance, how it is moving from -20, the 0, and this. So the profiling is also done. So this way you can like generate the L section, C section. Sometimes we need a, using a polygon also, we need a cross section of a particular area. So that also can be done. Like you can define, if you want, like vertical lines also. So you can get the vertical lines also. And in similar way, you will get the profiles of each and every section. And the same way you need to click on export, it would automatically compute at the backend and it would generate. So the same formats you get in here also, like CSV, DXF, and the PDF file. So the format is same only. Just
Hello.
it is the cross section of a polygon, and that was a cross section of a polyline. So that was the difference. So these are some of the planning tools which can. Hello. Okay. So these are some of the planning tools which I think should be handy to customers. And the main thing is like how these are, means the, how the important thing is not like are you using a DGPS or you are using a total station or you are using a drone survey. AutoCAD is our bread and butter in surveyor's life. So we need to like think like how anything can be imported on to AutoCAD, because at the end of the day, whether you use drone or total station or DGPS, everything has to be done in AutoCAD. So that is the main thing. So this is how you can like even the drone outputs
Quick question,
can
sir. A quick question. Sorry.
yeah.
Sorry.
Yeah, sure, sir. Go on.
This is only compatible with the AutoCAD or any other DWG softwares which are there, like
No, sir.
GQC, AutoCAD,
It
or
can.
any other.
So, sir, like, see, DXF, if DXF is compatible with any other software also, then it can be like Civil 3D and all, it can be imported there also. And
Again, Civil 3D also comes together. No, that is the problem.
what, sir?
Civil 3D is in part of AutoCAD, no?
Yeah, sir. So, means if you want some other formats also, you can request us. So that way, if like, if it is means required, we can provide the formats in other, means we can provide the results in other format also. One thing is like we provide CSV file also. So CSV file
Okay.
can be like, means using CSV file, it can multiple formats can more be generated, right? Because
Like,
most of the softwares import CSV files. So and then
yeah,
it can generate multiple formats. Then also we have a shape file also, which is compatible format for any
GIS.
QGIS or any GIS like your global mapper or any other software. Let me show you also, sir, like what shapefile is. So shapefile is basically it defines the shape. And let me put this in. So you would see like these are shapefiles, means the contour related shapefile.
The person you're
So-
calling.
So So you can see like this is a shape very generic shape file, and it can be imported in any software. Mainly we gave DXF because mainly people work with AutoCAD. Then of course CSV and this shapefile is a very generic format where you can import it in any GIS software, or CSV can be imported in any other software. So these are a few things. Now I'll tell you like I told you about the GCP and without GCP. So this project was processed using GCP. So in that you need to like first give the data of GCP, and based on the accuracy of the GCPs or like the DGPs collected, you get the accuracy of the drone output also. So here we placed around 4 GCPs, and you can see like we get a GCP report also, and you can see the error in X, Y, and Z is like 1.88 centimeter, 1.34 centimeter, and 12.4 centimeter. This is completely based on how accurate your DGPS is. So one of the thing is like the clients ask for the GCP report also, and this way you can generate a GCP report automatically.
Sir, we will get by using Google Map, you can able to draw contours and also area and what are the labels also. What is the difference with your software?
Okay, so sir, first of all, the using Google Earth, you get a very low resolution image of any surround or of any area. One thing is that the Google, when you see the drone imagery, it is very high resolution. The resolution can be in meters level when it comes to Google Earth, and when you compare it with your drone, it is like very high resolution. Another thing is like there is no such definite thing related to accuracy of a Google Earth. You may get a difference of 3 to 4 meters. I am telling you in meters also you can get a difference of 3 to 4 meters. Whereas when you survey using drone, you get the errors or the accuracy in millimeter levels. So these are some of the main differences which you can you can differentiate between Google Earth and the drone. Definitely you can get contours and grid points from there also, but it depends on the resolution, like the resolution and the accuracy of the result.
Okay, thank you.
Yeah. So this is I have generated a GCP report. Here again we can see like it is generated in 3 things. One is PDF format, another is CSV format, and another is shapefile format. So let me open this PDF file first. So you can see that we placed 4 GCPs, and individual errors also we get, like in particular GCPs, what was the error in X, Y, and Z direction. And so this can be like, sometimes it can happen like in one GCP you have more errors, and in rest of the GCP it has less error. This can be due to the fact like if many of people are using DGPS, so you may get in one float solution and in others fixed solution. So these all things means can relate to high GCP errors or low means the GCP errors. Then we have a shapefile also related to this. This can be imported in open source software. So, so you can see like these are the GCPs after processing. Okay. Okay. Now in this, like I was working in no UTM part. You can also have like different units also. Let's suppose you want the position format in decimal degrees. So for instance, you want things in latitude, longitude. So that way you can get the things in latitude, longitude, or if you want like degree, minute, seconds, that also you can do. So you get in this degree, minute, seconds also. One thing. So let's suppose you have marked. Let's suppose I have marked these all things. You can mark many more things here according to your needs, and if you want, you can export it in your AutoCAD also. Now there is an export all button. If you click here, so you would get the formats like DXF, shapefiles, and then you can like import it in your AutoCAD. So here you can make all the drawings, all the planning you can do here also. And let's suppose you can get everything like you, if you want to mark road, you want to mark any pit, you can do it and you can save it. And then after that you can like export it. So you can, if I just so you would see like whatever the markings was done here, it is reflected in AutoCAD, and these are also geo-referenced only. So you can import the ortho mosaic in the same fashion. You use a tool called GeoRef IMG. You select the ortho mosaic and it would be aligned on the. So you would see like whatever the markings you did on your software, it can be imported here also. So this is one of the features. Now I have told you about three things like ortho mosaic, DSM, and DTM. Another thing is the point cloud. So when it comes to DGPS or total station, you take points at let's say at 10 meters or 20 meters. But when it comes to drone survey, we take means these points are generated in such a way that you get points at every centimeter level. Let me show you a format point cloud where you would see like it is a 3D format, but it is made up of very billions and trillions of points. So I have a software called Cloud Compare. This is also an open source software, and you can like use a point cloud file. They can be in different format like LAZ, LAS, PLY, etc. So I'll just import this here. So for now you would see it is a ortho mosaic when you see it from the top. Just let me, now you would see this looks like a 3D model, but in fact it is made up of very tiny points. Let me zoom in. So as I zoom in, you would see like points coming out. So these are made up of billions and trillions of points. So you can think like how accurate this would be when you are moving from one point to another point. So this is one of the point where this is one of the output of the drone survey, a point cloud. Generally, a client asks this thing in LAZ or LAS format. So you can see at any point, it is made up of so many points. So this is also one of the format. Now there is another format, a 3D model format. So generally clients ask like how my mine is looking, or like I need it for a marketing purpose. So for that you can have a feature in our software which is a 3D model where you can view the 3D model of any project which you have done. This takes time. I have already downloaded it, so I will just show it in a Windows software. Like we have a software called 3D Viewer, and you can import the files of the 3D model using here. So So this 3D model is a big file. It takes a little bit of time just to open up. So you can see now the 3D model has been imported. So it does not have a point. It would just have it would just be a mesh and the 3D model. You can see here. So this is also one of the format of the drone output. Now, since I was talking about GCPs, I would like to like there are few things which needs to be kept in mind while when we use drone and the GCP. So the GCP should be like, there is a norm, like you should place only 4 to 5 GCPs per 100 hectares. So there should not be many GCPs to be placed in the mine, or let's say the designated area, because it does not increase the accuracy that much. It means a limited GCPs also can increase the accuracy. The points, like it should be kept at places where there is a abrupt change in the elevations. So these are some of the things which you should keep in mind. And then this is the export section. Like you can have the ortho mosaic I told you, so you can click on this export and you can download the file. So I'll just pause it now. Similarly, you can like, we have different. So I told you about the world file, which is important to import it in the AutoCAD. So you can download the world file. Now, if you want the result in JPG format or PNG format, so you can download it through here. I told you about the ground sample distance, the pixels. So this was the pixels at, means each pixels of the ortho mosaic. So the main result was generated at 2 centimeter per pixel. But if you want higher GSD, higher GSDs are basically used when like you want, because when the lower the GSD, I mean lower in the sense, the lower the number the GSD is, let's say 2 centimeter per pixel, the file would be large. So the 10 centimeter per pixel file would be small. So for planning purpose and all, you can use 10 centimeter per pixel file for the planning purpose. Similarly, I told you about the DSM DTM. DSM DTM, you can download it from here. One format we have is the slope map. This can be used for planning purpose and all. I'll just show you what slope map is also. It tells you the instantaneous slope at each and every point. Then we have another thing is like the point cloud and the 3D model which I have showed you, and then we get a project report. So in the project report, you get the project name, you get the total area processed, like how many hectares it was processed, the number of points you get. So you can see like here it had around close to 50 lakhs points. So this you can see the GSD of the ortho mosaic DTM, how many photos were there, the photo which was used here, and then the resolution of the photo, and what type of position reference was used. If only GPS is used or it is processed without GCP, you would see here only GPS. Whereas if you use GCP, so you would see both the things. Then you would get ortho photo in PDF format, DSM, DTM, and the GCP report. So this is the report, and I would just show you a slope map also. So the slope map you can see is like, you can see the variation in the elevation. It gives you the instantaneous slope of each and every point with respect to its nearby neighbor values. So you can see like how the terrain is moving from one place to another, how the slope is calculated. So this is one of the format. So altogether, this is all thing related to the drone survey, the ground control software, and the the drone outputs and how it can be made compatible with our day-to-day working using AutoCAD compatible formats or CSV formats or GIS formats. So I'll end my presentation with a small video. Just a moment. So this is all about the presentation. I'll ask my team to share the quiz which I told you in between so that you can fill out the quiz. The top 3 winners would be provided goodies from the Nivras Technologies Private Limited. And also you can ask your questions if you have any doubt related to drone survey or its output, anything.
Thank you, sir. Wonderful presentation. One question posted in a chat box by Joga Manikatta. Sir, how it's work on river areas? Hello?
Hello. 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 Am I audible?
Yes, sir. Audible.
Yes, sir. Can you repeat the question?
How it works on river areas?
You mean to ask the riverbed areas, right?
She posted a question like that, sir. How it works on river areas?
Okay. So it works on the same way only. Let's suppose you want to survey a riverbed area, or let's suppose you want to measure the river area only. So the procedure is completely the same. You need to fly the drone, you need to plan accordingly, and then you need to post process it, and you would get the similar results. Be it any survey, be it like terrain surveys or your topographical surveys, road surveys, riverbed surveys, or in fact for that matter monument surveys. They can be of different types of surveys, but the process is completely the same only.
In addition to that, in reverse surveys, you have any kind of drones where with the infrared or any kind of case, you know the bed level.
Sir, like we don't have the payload incorporated with this infrared, but there can be drones in the market where you can like use infrared as a payload and get the means the elevation or anything if you want.
And quickly, one more question: how much time do you require for the say 100 hectares and drone survey and processing of the survey data?
Okay, so I'll tell you. So I'll tell you about specific to our drone since we are we don't know much about our like other drones, but I'll tell you about survey and drones. So for 100 hectares, it would in one flight you can get almost 60 hectares, 55 to 60 hectares. So with two batteries, you can cover easily 100 hectares. So the field time would be less than 1.5 hours. The flight time would be 1 hour, and setting up takes maybe 5 minutes, and then so altogether in the field time you would get around 1.5 hours, and you can fly. Now when you come to the office, you upload the project, so you would get like in 4 to 5 hours. You would get when you upload the result and you click the start processing button. After that, after let's suppose the total photos would be collected would be around 400 to 500, and in 4 to 5 hours you would get the results. So in total, when you say using drone, you would get the results in 6 to 7 hours of 100 hectares.
Thank you. And if you don't mind, can you let us know about your costs, director?
So, sir, it depends on the means the because with the standard it costs less than 4 lakhs, the whole thing, the software as well as the drone part. I'll if you have asked, I'll just tell you about what the typical cost of the drone is in the Indian current market scenario, and then I'll compare it with my with our drone also. So in general, if you go for the same specifications of drone, you would get a drone of let's say 5.5 to 7 lakhs of rupees of a just a drone. And then of course if you want to buy a software not from our side, a desktop software, so it costs around 3 lakhs something. Now this software requires a very high processing PC because it processes the data, it collects, computes the features, and then it merges the feature. So it requires a very high end PC. So in that way, another 1 to 2 lakhs of investment is required. And of course, after this, you need a man, someone who would be monitoring your result and doing all the things. So this cost the typical if you want to set up a drone business and you're just starting a drone business, so it would cost you around 10 to 12 lakhs in general. Whereas with our ecosystem, you would get the drone in less than 4 lakhs, and then we have a software pay on use basis. So when you get a project, you process. When your client gives you the money, you pay us back. So in that way, you have less than 4 lakhs of investment and you get your work started. So this way we have reduced this cost of 1/3 to 1/4 of the typical cost which is present in the market. I think Kiran has shared one form. You guys can in the message box, I think it is there. I would request everyone to Hello. Hello.
Yes.
Yes, sir.
Yeah. So I think Kiran has shared the quiz form, and please fill up this form, and the top three winners would be getting the goodies from the neighbors. And if you fill up the form, we would be announcing the results soon only. And he has given like the quiz is open till 12:40. The quiz is related to what I have told you, most of the information. Yeah.
One question, sir, from our side.
Yeah.
Hello.
Yes, sir. Tell me.
Do you take up the job work of doing survey?
No, sir. So yeah, I'll just want to let you know. So, sir, definitely we do not take any job work. We are the pure manufacturers, and we are the pure developers of the software. I'll tell you also regarding this, there are many companies in the industry which you would find like those who are manufacturing also, and those who are like providing services also, which we find it little unethical, because I am the supplier also. So definitely I can manufacture at a lower price than what I am providing you, and then if I compete with you, so it would be little unethical. I supply you the drone and I compete you with the tenders also. So in general, I would say we are just the manufacturing companies, and whatever the job work if we get, definitely we get a lot of job work. So we redirect it to our clients, and our clients only do the job work.
Generally, what will be their charges, sir, per acre or per hectare? How they charge?
Sir, it completely depends, sir. It cannot be generalized, because it depends region to region. Some regions may means charge. If the area is small, I could say then the charge would be more. But if the area becomes large, the per hectare or per acre, the charges become little less. But it completely depends to the client, like if the client and the nature of the work, the nature of the output required, it completely depends on that.
Thank you, sir.
But you're not clearly indicating us what could be the hectare price or acre price. What our chairman sir is asking. Just indicate.
So the indicative price, if I want to give the range, it can vary from, let's suppose, 350 hectares to it can go up to 2000 per hectare also. So if the area is like the terrain area, so it is definitely a difficult area. So the charges would be more. But if it is a very large area, plain areas, the charges can be little less, maybe around 300 to 400 to even 500 per hectare. So that way the prices can go up. But sir, this is a very generalized thing. It means it depends on the various things also. Like if the client wants the results in a very limited time frame, 1 or 2 days, so maybe more drones or more batteries are required. So in that way, the means the customer would charge more from the client. If the timeline is very means normal, and then maybe 300 to 400, even to 500 per hectare is a decent thing.
And also I request what will be the best offered price, discounted price you are going to offer to our ACC members.
Definitely, sir. We can like have a conversation. What can be for, in particular, to people ACC, we can offer some prices to them. Definitely, we can talk to this about later on.
Discuss with you.
Yeah, sure, sir.
Our Rajkumar sir, who has talked to you right now, is a vice chairman of vice president of ACCI South. So if you, what he is asking is that if you give a comfortable price, it will be kept in our website and our members will get benefited out of it, sir.
Yeah, definitely, sir. We will like, sir, we can discuss on it further, like how we would like to collaborate with ACC and how we can go further. Once this can be done, like after this meeting, if
Thank you, sir.
okay,
sir.
so
Thank you. Thank you very much for your valuable presentation, information, and your time spending to our members. Thanks to all our ACCA members for participating in this webinar. Thanks to all students and faculties of engineering colleges.
Prasad ji, I am
India.
Srikanth here.
Thank you very much, sir. Thank you very much.
Okay.
Srikanth Channel, the governing
Srikanth
council
Channel,
member.
sir. Yes, sir, you can.
Yeah, but I could not come in between. I had a small query, but I don't know whether he can answer now or shall I talk to him later on if you are closing.
It is a
Problem, sir.
beneficial. You can ask now.
Okay, then just I would like to know what will be the maintenance cost.
okay, so sir, this drone is a very low maintenance device actually. If you would be surprised, but this drone is a very low maintenance device, and we provide a 1 year of warranty, and even we provide free services also during the warranty, like 1 or 2 free services. So if you think like you have a downtime of 10 to 15 days, you can send us the drone. We would see everything is fine, and then we would ship it back. So the in fact, if I'll tell you, the maintenance of this drone is very much easy. It does not require much of the maintenance. So that is what I can say. And also I can see one question, like we want to take any permissions for flying the drone. So yeah, I want to mention it about, like, we have a platform in which is called as the Digital Sky, and there the government has decided the norms. Basically, the government has divided the whole Indian map into 3 parts. That is red, yellow, and green zones. In green zones, you can fly without taking any permissions. Like, if you have a drone, you can fly the drone up to 120 meters without taking any permissions. For yellow zones, it is like you at till 60 meter you can fly without any permission, but after 60 meter, if it is nearby to the airport, so you need to take the permissions from the airport authority. Let's say if you flying near the defense area or maybe government area, so you need to, and if it falls under the yellow zone, then you need to take the permissions from the designated authorities. Also, now comes the red zone. So the red zone is completely no flying zone, and you are not allowed to fly the zone. I'll also share a link of this digital map so that you guys can take the note of it. So this is a very interactive map, and you can, like, before visiting to a site, you can just check whether at which zone your site falls in, and you can beforehand plan the things. Let me just share you the link in the message of the digital sky map.
No, you can share it to Mr. Durga Prasad. He will share it to all.
Okay, no issues. Thank you. Okay, like I think Kiran has said that we have got only 20 responses, but I can see like many people joined. So I would urge you everyone to fill up this quiz form.
Four zero nine four.
Hello? Thank you, Kakinada Center, for a wonderful webinar, and look forward for more such events in the future.
which is posted in chat box. Please answer the quiz and submit it at the earliest possible. Thank you.
We have done now.
Okay, one question I have got is like while using a drone survey, how to identify ground points like stones or any permanent poles. So yeah, that is a very good
We are
question.
concluding the program, sir.
Oh,
Thank you very
okay,
much.
sir.
Thanks to all.
Okay. Okay. Thank you, everyone.